Yeah,
Okay,
I'm recording.
also gonna start recording now. Okay, hello guys. I'm gonna be talking today about projections and inverse matrices, which sounds like a really fancy word, but it's not too fancy, so don't worry. Um, so yeah, we have this shot here from BOB. Sorry, it's a kind of a spoiler for anybody who didn't see it, but basically, um, it's gonna be very slow, but. Yeah, he removes Melina's face, and it's kind of a trippy shot where he removes Melina's face and reveals Natasha. So what we're gonna be talking about is how we had two plates, right? We had where was it? We had a Scarlett Johansson plate and we had a Rachel Weisz plate, and we had two separate head tracks. So we see if I can show this right here. So you see we have some wireframe. This is from like Keen Tools. So we tracked one face to Natasha naturally. I think we did use the same camera because the camera was probably just left in place. And then we just, on a separate work file, we tracked the Rachel Weisz or Melina head to her plate. So you have two separate head tracks. Now, naturally, the actresses are not doing the same thing, right? They're doing slightly different things. You know, they're looking in different directions. So how do you get it so that one head that's been tracked ends up in the position of the other head that's been tracked? And ultimately, that's the goal of this like presentation. But I think in order to explain it, we need to kind of go back and explain some other fundamental concepts. So I'm just going to start doing that now. So right,
Tony, sorry to
yes.
interrupt.
Hmm.
I want to ask if Salvador can press hide and scroll down a little bit because we don't see half of the node graph.
Ah, okay.
There's a hide on the sharing. And just scroll it down a little bit, or just put it.
And yeah, could you just go down a tiny bit, Salvador? I can also put mine up a tiny bit, like so. I don't think you're missing too much here.
No,
Yep, nice.
Yeah, cool.
fine.
Cool. Right. So let's go through this. So everybody knows how to apply materials to geometry. It's not Nuke 101, but yeah, you can either plug it in directly, right? Everybody knows that way. The alternative way, of course, is to use the apply material. So the first way you just plug it in the top. The second way you use apply material, and so the material's on the side, and we have the apply material. So instead of plugging into the geometry, we assign it after the geometry. And of course, this allows us to then use a stamp. So this is our preferred method. Now, if anybody is not doing this right now, you probably should, because these geometries do live in your script and they do slow them down massively. So if you start duplicating geometries everywhere because we're not applying materials, then you're going to run into some serious network and hardware problems with your computer. So I'm just demonstrating this. It's all the same thing, but we're going to be using this way. But just heads up, I'm going to be showing you both ways so that you guys can make the connections in your heads about how we're doing this. So here we have the plate, and we're going to talk about projections next. Again, it's pretty obvious, but we have a project 3D. Everybody knows project 3D. You make it at the top, then you plug in into the top of your geometry. So we have this beautiful Melina there, and then you have scanline renders, so we'd get the head in 3D space, right? So it's all projected on geometry. The alternative way, of course, just doing the reverse order, sort of. You have the geometry. The material is the project 3D. So this is a common misconception, maybe, is that the project 3D is describing the material. So the texture is the plate. How to apply the texture is the project 3D. It's saying apply the texture through the camera. What camera? This camera. Okay? And then that is together is a material. You have a texture, and instead of applying the texture on UV space like we did up here by just plugging it in, we're telling it, don't apply it on UV space. Instead, apply it to the camera. So project it straight to the camera. And so it's considering this bundle a material. And so you can apply material in the same way. So these two branches are identical, right? So they're giving the same exact results. Of course, as everybody knows, I think, when you move the geometry, when you use a project 3D, it doesn't work. And the reason it doesn't work is because it's still projecting through that camera. We defined the camera where to project from. The camera didn't move, but the geometry moved. So you would have to somehow link the cameras, and it gets really messy. And yeah, we don't really want to do that. So that's the downfall of this approach. That both of these will fail. So it will not work. You see the end result. It doesn't work. So how do we get around that easily? Besides, doing some crazy camera trickery, we use the UV project node. Now, the UV project node is a unique example of a case where it appears to be doing the same thing, but it is doing something slightly different, and that different thing allows us to use it in a more beneficial way. So we have the plate here again. In this case, I'm just going through the geometry method everybody knows. So plugging the top. So it's kind of, the order is, we need a material. The material in this case is the plate. So that's the texture. Just think of it as a texture. The texture is the plate. It goes into the geometry. Sometimes this UV project node yells at you if your geometry doesn't have normals. That's no problem. There's a normals node in Nuke. It's literally just called normals. So we use normals, and then you just set it to set action set. You plug it in, and it stops erroring, right? So that's just something that we need to do just because sometimes it yells at you. So after we've set the normals, we're using a UV project, and we're using the UV project with the camera. So the order of operations is different. From the top here, we needed to define the camera at the texture level. So we said, here's the texture, here's the camera. So the reason why the UV project is different is because we are actually changing the UVs of the geometry, and we're telling the UVs of the geometry to be from the camera space. So it's like, here's the camera, it's projecting, so the UVs become the projection. So it's actually overriding the geometry's UVs, which is kind of interesting. And if you don't know the UVs, I don't know if I could demonstrate it really quickly, but it's the, UV space. Here we go, wireframe. I'll just grab one of these. And just, if you set it to UV space here, I probably have an example already in the script, but we'll just do this. Yeah, and it needs to be some sort of square texture, I think. So I'll just make it a square. Yeah, so these are the UVs, right? So this is predetermined by 3D artist, and it's the infamous scary face mask thing. So that's the UVs of the actual geometry. We are overriding that with the UV project, and we're telling it, please just be the projection area from the camera. And so since it already has the texture, it already knows what the texture is, and now we're just replacing the UVs. Now it ends up looking correct. In this case, something is broke, or maybe it's not broken. Let's see. No, it's fine. So I will demonstrate in 1 second the UV thing. But yeah, so what this allows us to do is then we can use the transform geo. Why does it work now? It works now because we've replaced the UVs, and so they're like baked in, they're already set. And so now we're just moving the geo. So if you move the geo after the UV project, then it's working because the camera, it's almost like it's bundling this entire top section. So it's bundling the camera, and it's bundling the geo and the texture, and then you're moving them all together, whereas before it was sliding around. So that's the difference, and I probably should have shown you this branch, but yeah, we have the geo, we set the normals, we apply the material is the plate. So it takes a while to kind of think about it like this, because you want to put the camera with the plate, but then we set the camera afterwards, and here we go. That's why it's not working. And that allows us to move the geo or rotate it or whatever we want to do. So I can rotate this completely. Oh, that was probably not a good idea, but we can see that it still works somewhere. I don't know where it went. Let's do this. Yeah, these things they get kind of funny once you move around in 3D space a little bit. So yeah, you can see that even if we move her, the texture is still there. So that's how you move something with a texture. And let's see. Yeah, I already did the UV thing here. So here is the example. Oh yeah, I already set it up. I already forget. But the UV project, if you're doing that, if I set the scanline render to UV, this is considered the UVs from the UV project, which is just the angle of the camera. I don't know. I'm not sure if that's making much sense, but this is the UVs from the regular geometry, and this is the UVs after we replace the UVs with the camera. So it's literally just camera space, like UVs, like you projected it onto it. Okay, so that's all well and good. So, what's the next one here? I'm moving it around. Just gotta get my place here. It looks like it's about the same thing. So right, let's move on to the next section. So we kind of all got that. Once UV space allows us to move back and forth, it's all good. So let's talk about the next step, which is stabilizing match moving 3D objects. So I don't want to insult anybody's intelligence, but we're going to use a basic 2D first. So here I just tracked, I don't know, this guy's nose or something. So we have a basic 2D track. It's got some motion on it. So here what I've done is I've put a color wheel, but instead of the color wheel being at the center of the screen, the color wheel exists at 0, 0. So you just have to trust me. It goes like 50 pixels in negative and positive and negative. So the reason that I did that is because you know that this little corner of the screen is like 0, 0, and it's basically a 2D origin place, right? Um, that's where it needs to be to have some positional data. So what we could do is first position the object to where we want to be around that guy's nose, and then just apply a match move to it, right? And so obviously this is not rocket science, but now we have an object. So first we positioned it, then we applied the motion from the camera. Um, and of course, you can just invert those. So then you reverse the movement. So then it's just stuck in the original position, and then you reverse the position and it goes back to 0, 0, right? So even though everything is animated in both of these sections, the color wheel is not moving because we've just inverted everything, right? So obviously we can consolidate these transforms, and so you can just do it all at once, right? So even though that this little color wheel started at 0, 0, we can just match move it. So this is containing the actual information. And then, of course, we can just invert that, and it stays 0, 0. Now, it's obviously very easy, but we need to think about how to do this in 3D space. What is this? Starting from an anime, I already forget what I wrote here. Starting from an anime position, returning to base, applying texture. Oh yeah, so what can we do with this? Of course. So why would we ever want to like return it to that position? So I'm sure most people have done this before, but say you start up here, so you start with this animated thing, and then you return it to the base position. In this case, I drew a little smiley face on it on the base position with the roto paint because it's not moving, and then you apply it, right? So return it to a stationary position, do something to it, and then return it. So now I have a nice smiley face. So I'm going to be calling it a position. What is it? Animated position or transform position and base position. So base position in this case was just at this little 0, 0 space. Apply a little overscan to it to see the smiley face. Boom, and then put it back. Right. Duh, pretty obvious. How do we do this in 3D space? Okay, so this is where matrices are starting to get involved. The matrix is just this 3 by 3 grid. If you see here, or I'm sorry, it's a 4 by 4 grid, or in if it's describing 3D space, right? So this is where you can find the matrix information. And basically, in a nutshell, um, us as users, we like to use transform, rotation, and scale. We like to use these guys up here, but um, that's not how the computer likes to deal with it. The computer likes to deal with it in matrix form and matrices. And as you'll see later, it's once you start layering complexity and like really stacking transformations on stuff, then it's much more easy just to multiply a matrix together and get a result versus trying to um, figure out the math of all these different knobs of translate, rotate, scale. So let's go through this together. Here I have a nice, beautiful world, and I am setting a position. So I don't know how many people do this, but there is often a want to animate stuff from this from the object level, from the sphere. But generally speaking, it's better to use a transform geo and then use an axis for your transformations. And the reason is, if you just use this as apply transformations, is what I like to call it. So if you use this just as a node just to apply the transformations, then you can do all your transformations here in your axis. So you can mess with the translate, rotate, scale, and that keeps them separate. So then you could replace it, for example, and then you could do something else. Just as an example, versus messing with all the settings of the sphere. So the sphere is default. I didn't change the sphere, and I'm just doing all the transformations here. So in this case, I squashed and stretched it, right? So I wrote something here. Yeah, translate, rotate, scale, great for the user. We can understand it. We get that that's what it's doing, that we can visualize that. But yeah, the 3D stores the position using matrices, and they revolve around matrices. It's one of the oldest 3D systems. Like every 3D application uses it. So here we have the transform position, and obviously, I think what I've done here, just as an example, is you take this, and everybody's probably done this before. You go through, you negative everything, you make everything positive where it's negative, and then you do 1 divided by for the scale. So I've already done that. I've done it here, and I did it manually just to say you can do it. Of course, you can do it if it's easy enough. So the sphere was at the base position, so it was at origin. Origin space is 0, 0, 0, 3D coordinates 0, 0, 0. And then we moved it, and then we painstakingly and manually inverted that movement by making everything negative and inverting the scales. And then once we apply that transform of the inverted axis, it goes back to 0, 0, 0. It stays in the center. Obviously, things can get out of control. Oh, by the way, if you didn't know, I should mention this. If you do ever do this negativing out the translate and rotate, and if you 1 divided by the scale, you need to change the transform order here, and you need to change the rotation order. So that's another painstaking thing, but basically before it says SRT and ZXY, and now it says TRS and YXZ, and you need to just reverse all that stuff in order to do it. But that's a fool's errand. We don't want to do that. That's how. It's not a great way to work. We should work with the matrices, because once we understand them, we can use them to our advantage. So here we're going to do it with the matrix instead. So we have the world again. The world is at origin. And here we have a more complex situation, because I've stacked a bunch of axes together. So I don't even know where this world is. Oh, it's because I didn't. Yeah, there you go. Let's see if I can get this. Here we go. So it's somewhere in 3D space. So in this case, you would have to plus all of the transforms together. You'd have to figure out how the scales were all working with each other. That's just too slow. It's nonsense. So we don't want that. So there's a few tools that can help us. So, but the first thing I should mention is that each axis node has two matrices. One is local. So the local matrix is telling you what this axis is doing. So the transformations that this axis alone is doing. Now, the more useful thing, I think, is the world matrix, which is where is this axis in 3D space? How is it rotated? How is it scaled? So that's how it exists. You can see if I unplug one of these axes, the bottom matrix changes because the position in the world has changed. So where it lives is changed, but the actual information of the axis itself didn't change, so the local one didn't change. If I start changing this stuff, you can see both will change because now I'm changing the final position and the axis. So I'll just see back there. So um, there's a few tools for inverting a matrix. I did make one of myself, and I will plug my own thing, but they all basically do the same thing. And so these folks, including myself, have painstakingly gone through the trouble of learning about how to inverse a matrix, which if you ever want to punch yourself in the face, go ahead and do that on your free time. But the point is, it's not as simple as negative and inverting scales. Like, it's a whole equation, and I don't know if the equation's written here, but each one of these things has its own matrix inversion thing. So we're not gonna go too much into it. Maybe this guy has got it written. Yeah. Anyhow, what can you do with this? So this, the same way that a stabilize will undo what a match move did, this undoes the movement uh, of the matrix that you have plugged into it. So in this case, I'm just going to use this one. I think it's called Matrix 4x4 Math here. Oh, I'm sorry. Matrix Inverse. That's what it is. Matrix Inverse. That's what it is. So that's how you could find the tool yourself. But you could either select from the input, the local, or the world. In this case, we want the world, but I already explained the difference with the two of them is this needs to be plugged into something. If you plug a dot into it, it breaks. So sorry. But yeah, so it's going to take the world matrix of this axis. Where is the axis in 3D space? And it's going to invert it for us. And once again, this is not as simple as just negativing stuff out. So from there, you can, for example, make a static frame, which I've already done here. And since this is not animated, it wouldn't matter what frame I did access. But instead of using the translate, rotate, scale, you can actually turn on the specify matrix, and you could define the matrix yourself. So that's what this thing is doing. So we're now plugging in the inverted matrix into this axis, and I will now quickly get to the point. When I view this, the world is back to the normal position, just like what we did before when we inverted this axis. Instead of inverting it up here in the translate, rotate, scale, we've inverted it using a matrix, using all these guys here, and using that tool. So that's all well and good. So we use the matrix, and I want to be very clear. This puts the object back in the origin space. It puts it back in the center of 0, 0, 0. It does not mirror the image, because I think when people are thinking about inverting it, they're thinking about mirror. This is very similar to how way up here, this color wheel, how it was at 0, 0, 0, and then it was moving, and then we undid the movement. So it goes straight back to 0, 0, 0. That's exactly what is happening in this position here. So yes, let me just catch myself here. Yeah, so what did I say here? Inverting matrix gives you 0, 0, 0. Another way of looking at it, inverting the matrix stabilizes the object at origin. So let's go into another more complex example. So I thought it would be fun to make a small solar system, or not solar system, but just worlds. So here we have some motion, right? We have the world with giant spikes going through it, and it is, yeah, moving around. So all of these axes are doing different things. Some of them are animated, some of them are not, and it's, in order to do the math of all this stuff, it would just take forever. It's just not a good approach to it. Now, I did make this tool available so that it is live, actually. You don't need to bake it. Baking it is just convenient, but you don't need to. So this is live. Inside, there is an axis that is already inverted. So even just plugging this inverse matrix in, we can undo all of that motion. Let's see if I can get this. Sorry, it's my... Sometimes a 3D view doesn't want to show me stuff. Here we go. So let's see. We've moved it, and then we undid the movement. So even though this thing, this Earth was moving previously, up here it's moving. I don't know where it is in 3D space. Sorry. Up here it's moving. So now it's just stuck. Oh, there you go. You can see the axis moving around. There it is. So before it was moving, now it's stuck. Now this is all live, so it's similar to looking at a match move and then stabilizing it. Like, so it was moving around, but now the matrix is inverting frame by frame live with an equation, and it's stuck. It's stuck right in the origin, so it's just sitting there, right? So what we can do from there, once it's stabilized, for example, is let's do the smiley face example again. So I have a camera here. I just set a camera. If you don't know, you can just make a camera here. You can just like create a camera. So that's what I did. And we're going to view through the camera. We are going to draw an amazing smiley face. I did have to fix the aspect ratio because this was some anamorphic framing. So we're going to apply what we did in the previous section where we're applying the geo. So we have the geometry. In this case, we have the texture. The texture is the smiley face. Now I need to tell it what camera to use. So I'm using the projection camera. So I'm using UV project. So now we have this thing projected. So it's all nice and good. That means that once I apply back the transformations, so here I have a stamp from the original revolving world, and I'm applying the transformations. And what we're going to get if I render this out is a revolving smiley face. I'll just view the end result, but here we go. So I think I probably need to slow that down maybe a little bit. Here we go. So we have a world with a smiley face on it. Now there's some important things to mention here, which is number one, why did I not use Project 3D? If I used Project 3D, then the camera would have been in place, and once the world started moving, it just would have been sliding through the smiley face, okay? So in this case, we did need to use UV project so that it moved with the geometry afterwards. The problem with using UV project is that we've destroyed the UVs. So this was kind of a good case because I already had a texture, which was the map of the world. So I already had a texture. So if I replace the projection camera, then it's going to project the map of the world through the projection camera, which is not what we want. So after we've done this projection, basically the projection only works for the smiley face that I did using this camera, right? So we have to split the streams up. So here I have just the world moving around, and then here I have the smiley face with the UVs that have been now completely replaced. And I've rendered out the smiley face as just a black and white matte, or an RGB texture, whatever you want to render it out as. And then we have to combine it afterwards. That is a limitation of it. Maybe there's some way to specify UVs of using both at once. I tried playing around with like blend materials and merging materials. It doesn't work just because of, basically because we're destroying the UVs at some point. So I don't think it's possible to have two sets of UVs in one geometry. So, and this is a limitation of the process. But as you can see, we stabilized the Earth, we drew a face on it, and then we returned it to the original position, right? And you might say, well, yeah, but I could have drawn the face on the original position to begin with because we started up here in the original position. That's true. But if somebody gives you something from 3D space, then it's not true anymore. It's already animated. And so we can use this to unanimate something that has already been previously animated do something to it, and then apply the animation back. And now we're going to get into the actual real-world example from Black Widow. So this is straight from the script. I did clean it up a little bit, but for the most part it's there. So let's get into this. I probably need to view some access. 1 second. Right, here we go. So we have Rachel Weisz here. Let's see. So what we did here is we have the geometry, and we set the normals because that's what it wants. Then we have, well, in this case, I have an extra card here, just placed so that it catches some of the edges of the stuff that didn't catch on the geometry, because the geometry is a certain position. So if her face goes a little bit outside of that, you want to catch some of that. And I'm just gonna go through this. So we have the plate. Here's the plate here. And once again, we're applying the material first. So this is not making much sense up here, but as soon as I apply a camera to it, it starts to make more sense. And I have to turn off the light there. So I could take away this card for now if it's a bit easier, but basically, yeah, you have her face there. So this card was I'm tripping myself up with this card. So basically, I had to set the card in a base position, so the 0, 0, 0, and then I'm just applying her axis. So let me just tell you what we had in the beginning. It probably makes more sense this way. We have the Melina head geo, which I don't like this, but it's doesn't like to show me things in 3D space. But we have the Melina head geo, which is the head track that was tracked to the plate. And then we have an axis for that. So that is the transformation data of the head tracked to the plate. And then we have the reverse of that. So we reverse this axis, and we have this exact reversal. So once we apply that, it will go back to origin space. And then, of course, we have the Natasha head here. I gotta hide one of these. Or not. Yeah, okay, so we have the Natasha head, and we have that position, and we have that inverted axis as well. And yes, trying to be very smooth here. So 1 second. Okay, so what we have to do is we put Melina's head at origin. So here we have the head moving around. So it is indeed moving. I have to turn this off, and I will turn off this card. So this thing is actually animated. It's not moving too much, but it's animated to her head. So the first thing we need to do is zero out the transformations. And it's so difficult to view this stuff in 3D space. But her head now is at should be at origin space. So I just view this. There you go. So her head it's now sitting at 0, 0, 0. So I've canceled out all of the animations. And now we had Natasha's head. So we have the transformation of Natasha's head. So instead of putting the head back to where Melina was, I've put it back to where Natasha was. So I've stabilized it and then used a different match move. So I've put it back. So it's in a slightly different position. And I don't know if the best way to illustrate that is, but basically, I think I can grab this guy. So if I view this, if I view where it was before, which would be up here, and I view it now down here, you can see that I've changed the position. So I've stabilized it, and now I'm not using the same match move. I'm using the match move from Natasha head. So that's pretty much what's going on there, and you can see. So as we said before, the heads weren't in the same position, so you need to get one face in the position of the other face. And why are we doing all this like in 3D projection setup? Why not just do like unwrapping the UVs? One, UV space, it will lose texture quality, big time, because you have to go into 2D. It's slower because you have to go into 2D and then you have to go back. And second of all, the UVs only cover a certain amount, right? So if you have eyeballs or something, there's no UVs on the eyes, and you might see seams on the side of the face. And you can't do stuff like this up here, which is put a card to catch all of the stuff. So once again, I'll show you the before and after. Um, so I'm catching all of the hair and all of that stuff. So I'm repositioning like the whole plate um, together. So all of this stuff you can't do. So texture hits, um, convenience, speed. Um, it's all reasons for doing this. So let's go through it now. I'm filming it through the plate, and this is the end result here. I don't know what happens if I. Yeah, so if I let this cache for 1 second, so this would be the original position of the head, and this is sort of where it went to, and it looks really subtle, but you know she probably turned her head like 2 degrees or something, and all of that you do notice at the end of the comp. But from this base position, from when it was in the origin space, which I'll have to use this, from that base position, we can do other things. So what I was doing was, here I have this head projection card. So yeah, this is this is what I was trying to say before, is that I made this card here when her head was in the resting position. So it's at 0, 0, 0, it's at origin. I made a card, and then later on I took the card and I brought it up here, and I just applied her animation to the card, which means that her head and the card move exactly the same. But here, in this case, I did it because I wanted to do some roto shapes. So what I did is I have a custom camera here, or I don't even have a custom camera. Even what I did was I took the actual master camera, the plates camera, and I inverted it and frame held it. So what I do get is exactly the same thing as we view frame 1, but everything is just static now at origin space. And then I just did some rotos. So I just rotoed some face masks and stuff. So this roto is all on 2D space, but it's, yeah, getting appropriately added there. And just like I did before, the roto is the material and the camera is the projection. In this case, I have to use this made-up camera that we used before to freeze it. So you have to link the texture with the camera. So use the camera as a preview. So here's the preview, and now I'm using the camera to apply what I have rotoed. And then I'm just, once again, applying the same match move that I did here to that thing. And what we get at the end is a face mask here. So we have the whole face unpremulted here, just so in case we need to change the mask. And then we have the actual mask here moving with all the movements and stuff, with all the subtleties. And it's not like a frozen face, by the way. This is like the plate. So all of the little movements she has and all the lip movements and stuff, that's all being captured here. So it's not like I froze a texture or anything like that. It's all being live driven through this setup. And I think once again here, I think I just, yeah, I wanted to see if this matched with the plate, and this one, yeah, matches with the new position. So once I have those two, I think I did some nose fix because, let's see if this shows it, but yeah, I don't know if you can see, but there's like a few pixel gaps. So if I go back to the original plate here, you can see that because she moved, you get this little bit of movement here. So something that I needed to fix afterwards, but it wasn't really that painful. So it's basically the nose projecting onto the cheek behind it. And yeah, so I have some color corrects, and then I apply the alpha, and basically I distort it and put it over. So I don't know if we ever saw this Natasha plate. So this is the actual plate of the shot. I'm using some prep of it. But you can see she has some specific movement here where she moves the face. And now we have Melina's head basically tracked with the movement of Natasha and a very creepy looking shot. So yeah, that's pretty much it. That is how you would project something in a way that you could stabilize it, apply a new transformation to it while the texture is live, while you can catch all the edges and everything like that. Yeah, making a really creepy shot. So if this was a more extreme shot where they were both moving, like if she was turning her head, 20 degrees, as long as the plates action was very similar, I mean, you could do the same exact process because we could turn this head. I don't know if I can do it, but basically, let's see if this works. But if I just turn this 1 degree, what happens? Anything? So we have some degree of movement here. It's quite interesting. Like we can actually turn her head like full profile view, and it's looking like it's the main plate. I mean, it's not really losing. This is all one. It's considered one transformation, so that's why it's not losing much quality. Versus if we went to UV space, then it loses texture hit. Then we reproject it, then it loses another texture hit. So then it would get a very filtered. But in this case, it's all just doing it kind of on the fly. So yeah, sort of an interesting setup. And sorry I didn't get a chance to get to the UDIMs or what was the other thing? Or the PREF task. But yeah, this would be it. So hope you learned something about projections in inverse matrices. That's a bit early, I guess. Does anybody have any questions about any of this stuff? It's kind of a different way to think about 3D and projections and stuff. I'm not sure how many times this actually comes up on a show, but yeah, I know that 3D often renders like a series of axis locators with the geo that they have, and yeah, you can use some of those individual axes to actually take the geo. Like say you had a character, if it had a head axis, you could use the head axis to basically stabilize the head. I know Michelangelo did that once. I don't think I have an example in the script, but basically it would stabilize just that section of the CG, and so then you could project something on it and then return the position back to the original position. So yeah, I'll make the script available for everybody in the tutorials folder. I hope it was kind of useful, and maybe it would help you in the future. And I really do recommend using the inverse axis things too. And don't think of it as big, huge math. Just think of it as stabilizing a match moving in three-dimensional space. So I think that's really the best way to think of it. So cool. Oh, and you can, by the way, you can bake this out. I forgot to mention that. So you could frame range baked. What is this here? So I think I can bake this. It takes a second, and this thing is now inverted and baked. So that's how you would do that. Or you could use it live, as I did. I don't think there's any processing time loss using it live, but in case you unplug something, it's useful to have it baked. So yeah, guys, thanks a lot.
One thing
Thank you, Tony.
Oh yeah, go ahead.
Sorry, Tony. I would like to add something. It was very helpful sometime when I had to stabilize like a face for a shot that I was doing for a project. We need to apply some tattoos on the face. So on the stabilized thing, you can apply motion vector, and you're gonna get much better results than just apply motion vector on an animated face. So that also one additional thing that I'd like to point out. They can be helpful sometimes.
It means using smart vectors, right? To the
smart vector over the 3D stabilization in case. to catch all the motion of the face
Mhm.
that otherwise get lost.
Yeah, basically taking out the overall motion and just focusing on the little subtle motion
Yeah,
of the
exactly,
face. Yeah.
exactly.
Yeah, and you could do that from this projection camera basically. So if you had some movement or something, you have this. I don't know what happens if I'm moving this around. Yeah, you can see her head is like stuck.
Mm-hmm.
I don't know if it's very clear here, but let me put this on a lower quality. But her head is it's like stuck in place. But you can see her like body and her neck and everything's like moving around. But that allows us to like make a mask for the eyes or anything. Uh, and this whole thing is live. I think I had some example up here. If I do this, like if I make a roto shape for just her eye at the beginning, uh, you could see that it's all like tracked in there. It's all live. If I went back here and changed this again to uh, something else, you could see that it's pretty quick actually. It's not even that slow. Um, anyhow, yeah. So this would be a great position. So also to your point, maybe Michelangelo, it's a pain in the ass to view things in UV space. So instead of viewing it in UV space with her head like all splayed out,
Mm-hmm.
like like a Michael Myers mask or something, you can you could stabilize it like this and then use the camera. So then if you had one frame where you wanted to project the tattoos on, you could use this method and then you could apply the tattoos back
Yeah, exactly.
to the face like
Yeah.
this. So just an alternative way of doing it, I suppose. Yeah, because nobody likes to view things in this mode here. Nobody likes to view things in this 3D mode here.
Mm-hmm.
It's not
And
very flattering.
so I had a problem. I did it in 2D, but I guess it applies here too. Usually you have two faces or two objects that you need to combine between basically a face swap. Um, but they both have their own animation, like you said. Here, what you're doing, you're stabilizing one and then reanimating with the other.
Hmm.
But sometimes you need um, the animation um, from the first one to kind of continue on. Add, you need to blend between the two animations in some sort of a way.
Yeah.
How would you do that with Geo though? Like I know how to blend transforms, but how would you blend the animations in the axes?
You want to blend the axes together?
Yeah.
Yeah, okay, we can do that. You can't blend the geometry together. If you need to blend geometry, send it to
No, no.
Houdini.
Yeah, yeah. But
uh, but here's the two axes. Oh, let's get the real ones. Okay.
there are yeah actually geos you can there are plugins, but I guess
Here's the two. Where is it? I guess these two. Are these right? Let me just check if there's a difference between these two. Oh, there's no difference between these two.
Yes, there is.
Okay. Okay. There's for some reason there's a difference between. Yeah. Am I just? Oh, here we go. I'm just crazy. Let me double check this. Yeah, there's a difference between all three of these. Okay. So let's do between this one and this one, right? So we have one Natasha, one Melina. We'll just do this. So let me think about it for a second. There is the what is it called? Is it the distance? No. I can't even remember. That's why I have all this stuff. It is called it's called mix or something like that.
There is one called blend camera, I guess.
Yeah, that's what I'm. Is that what it's called? Did you do that one? Blend.
I'm not sure, but I think so. Camera blend, maybe.
Oh, I can't for the life of me. I can't remember what it is called. 1 second. Here I thought it was gonna be real easy. Distance between, maybe? I don't think that's right, but no, that's a distance. That's actual distance between. There
Aitor is saying fusion camera.
Fusion camera. Well, I don't have it. If anybody has it, they can send it to me maybe. But there is like a really easy way to do it. Let me think for a second. Because I know how to do it with one knob, but I can't. Yeah, I'm gonna have to come back to you on that one because I don't remember.
Yeah, it's fine.
3D distance, because you have these 2 points here to get the distance. But yeah, there's this really nifty. Let's see if it works actually. What's it called? It's the curve tool. No, it's the wave grade mix. waveMerge. Can't remember. I think it's right here. I know we have like no time at all, but
Yeah, I don't want to take any.
I think it's this one. But it probably only works with one output. Yeah, anyways, sorry. There is totally a way to do it, and I'm sure there's a tool. If there is a tool, tell me and I'll add it.
Yeah,
I can't remember.
I'll Google it. It's fine.
But
I'll
this
look for it.
this wave, this like dissolve thing, this will help. So if I have something animated here, like this, like if I do something like whatever, this thing, if I have this, I'm not sure if I'm going to screw this up already, but let's do that and something else. So this thing will, what is it looking for? Hold on. It's looking for operation. I can't remember. And this, you can like take the two curves, but it's looking for something specific. I guess it's looking for the wave maker. Wave maker. It's basically looking for these two things, but I'm not sure if it's, yeah. I don't know if you can see here, but I need to change the seed of one of them probably, or the plane or evolution or something like that. So this thing allows you to blend between the two. I don't know if you see what I'm doing.
Yes.
But that's the key. That's the key to doing that. Is basically you.
Yeah.
But you just need to find the right tool to do it in 3D space. But yeah, it's totally possible.
All right. Thanks.
Yeah, no problem.
Sorry, guys.
No, it's cool. That's a good question. Cool. All right. I'm gonna end this here, and have a nice day, everybody. Thanks for listening.
Thank you.
Tony.
Thank you.
Thank you.
Thank you.
Bye. See ya.
Thank you.
Bye.
Thank you.
Bye-bye.
Bye bye.
Bye, guys.